All right, folks, I'm going to do a quick look at this problem. This actually came from a PSAT practice test. Let's start just by reading the question. It just says, Salma completed a downhill ski race. The graphs below represent her elevation over time and her distance traveled over time as she raced down the mountain. Now, there's two graphs here, and really, my reason for presenting this problem is really about getting a chance to look at graphs that have a whole lot of information and that really tell us a story about something that's going on. This lady is skiing down a hill. And I want us to start to get in the habit throughout this week of really looking at graphs and tables and equations and stories and pictures as ways to tell stories that have measurable things, and that's where the math comes in. So we're going to really focus in on this first graph that looks like elevation and time. And I've sort of blocked out everything else out, and we're going to sort of take apart this graph a little bit and see how this graph tells a story just like a picture would. So the first thing that I'm going to notice is this point here where the time is 0. So 0 seconds have gone by. This is the beginning of our story. And this is our y-axis. This place where our graph hits that y-axis has a special name. That's our y-intercept. I'm sure that you probably have touched bases on that throughout your middle school. But this tells us the beginning of our story. When the time is 0 minutes, she's at 2,500 feet above sea level. Now, that's elevation, and we know that elevation is something that here in the Mile High City, we're at 5,280. So this is 2,500 feet above sea level. Now, we're going to sort of sketch that out in a couple of minutes to make that a little bit clearer. As time goes on, half a minute in, she's lower. And as time goes on, she's lower until 2.5 minutes later, after her start, she's at 500 feet above sea level. Now, for me, one of the things that I always want to do, and maybe I just do it on paper, maybe I just do it in my head, but we're going to do this today just on paper here, is I like to actually take a look at what a sketch of this would actually look like. So I actually sketched this out a little bit. And so here we are. So here's Salma. She's got her big long ski pole here. She's started at 0 minutes, not 0 seconds. We're at 0 minutes. Let's fix that here. Minutes. At 0 minutes, she's at 2,500 feet. She's going to go down the hill. We can see that her elevation is going down as the time goes on. We know where she's going to end up at the end of this. At 0 minutes, at 2.5 minutes, she's going to be at 500 feet above sea level. Here, let's see here. So the next thing that I did is I started to take a look at other points. What happens in between here? Now, again, throughout middle school, a lot of times what we'll do is we'll take that information and we really want to, when we want to look at a number of different points, sometimes making a table so that we can sort of take it apart makes sense. So here I've got at 0.5 minutes, I'm at, what is that? That's at about, 2,200, 2,250. So actually we should fix that. We should put that in here. Let's see here. Let's put that point in here. We'll move that down here. Make that quick fix here. So at 0.5 minutes, we can also say, she's at 2,250. That's halfway between. Here is at 1 second. She's here at 1,500 feet. Now, one of the things I want you to notice here is the shape of this graph. This is telling us something about the skier. When you're seeing this graph and you're seeing these areas where this is a short period of time, half a minute, she's dropped now from a half a minute to 1 minute, she's dropped here by 750 feet. Here, 750 feet in only half a minute. In this first half a minute, here from the beginning to that half a minute mark, she's only dropped 250 feet. So here, she's dropped here in the first half a minute, 250 feet. I can see that if I subtract these numbers. But in that next half a minute, same amount of time, here this was half a minute, and here another half a minute. She dropped 750 feet. In the next minute and a half, she drops 1,000 feet. So what we can do is we can take a look and see how fast is she dropping. Here in this first section compared to this second section, this first section, she's not going quite as fast. And I think that makes sense. When you first start out skiing, you might be going up, you might have to push off and might not be going quite as fast. So we can take a look at these different parts of this graph and tell this story about this skier. Now, this next graph tells us two different stories, and I want to notice here that while we know that her elevation is dropping because she's actually going down the hill, here she's traveling the distance. She's moving forward. So her distance is increasing. She can't say, oh, I didn't ski any distance, or I'm skiing less and less distance as the time goes on. She's skiing more distance because she's going forward. So it makes sense that at the beginning of the race, she hasn't gone anywhere. She stopped. She's waiting for the starting whistle. Then she's moving and moving and moving. She's going distance. So these two graphs tell a very, very different story, but about the same skiing race because we're measuring two different things. Here we're measuring the distance that she's traveled. Now, this last part, we can take a look at the question again and actually answer it. And I'm going to give you just a quick minute here. I suggest that you pause the video so that you can see if you can answer this question, and then I'll go over my answer. Pause it now. And here's my answer. And it's simple as this. We're wondering what will the total distance be when she has reached an elevation of 1,500 feet. So I go to my elevation, I find 1,500 feet. I go over to my graph and I read down, oh, well, that happened at 1 minute. Well, how much distance has she traveled at 1 minute? So I go over to this graph, I go to 1 minute, I go up to where the curve is, and then I go over and I read, oh, well, that's between half a minute, 0.5, and 0.75 minutes. It's halfway in between here. So it can't be, it's not going to be greater than 0.75. So it can't be this 0.9. It's certainly not going to be up above 1 minute. It's down here. So these two answers are out. The only answer that makes any sense and that falls right in this area is this 0.6 miles. The last thing I need you to do during this asynchronous time is to go back to Schoology and find the link for the exit ticket and make sure that you take that, make sure that you submit that today. Thank you. Have a great day.